Hello students, welcome you once again to GK's maths classes in the series of 5 problems per session under JE mains. We are going to do 5 more questions today. I hope you have gone through my first 2 videos where I have put 5 questions. Now we have completed 10 questions of sequences and series, and this is the next set of 5 questions. They are very interesting problems. I hope it will be of great use to you. In the next video also I will be putting another 5 questions and sequences and series. Maybe we'll target say around 50 questions and sequences and series before you jump on to the next chapter. Okay, I would kindly request you to provide your support as you have been doing it till now by subscribing to my channel and also to click the bell icon to get notifications on all video. So straight away let's go into that problem. Okay, the first problem is here. Very nice question. Let A, B, C, D are positive real numbers. A, B, C, D are positive real numbers such that A plus B plus C plus D is 11. If the maximum value of A power 5 B cube C square D is 3750 beta, I want to find the value of beta. So what I am going to do, first of all, let's write what is given. Now for me the given quantities are, just a second, change this. For me the given quantities are that A plus B plus C plus D is 11. And one more important thing is given, that the maximum value of A power 5 B cube C square D is 32, is 3750 beta. So this is what is given. Okay, the maximum value is this. So that means definitely, you know, this is definitely greater than or equal to 3750. Okay, 3750 is the maximum value, so it can't exceed that. So 3750 beta must be less than A power 5 B cube C square D. So this is known to me. This is what is given in the question. So let us be there. Now what I will do, since this is A power 5, I am going to write A as A by 5 times. A by 5, A by 5, A by 5, A by 5, A by 5. There are 5 A by 5s. And I am going to write B as 3 B by 3. Why do I write 3? Because it is B cube, I want to connect it. Since it is B cube, I want 3 terms. So 3 B by 3. Since it is C square, I will write C as 2 C by 2 plus D, there is no change, call it as 1, call it as 11. This is what you have got, correct? Now, what is the question? A, B, C, D, all are given. Now, I am going to use a relation of arithmetic mean and geometric mean inequality. So what is arithmetic mean, geometric mean inequality for, say, numbers from x1, x2 up to xn? The formula is x1 plus x2 up to xn divided by n, that is the arithmetic mean, is definitely greater than or equal to the geometric mean. What is the geometric mean? Nth root of product of all this. So I am going to make use of this result. Now what is this x1, x2, x3 and so on for me? It is basically, these are the numbers. Okay, so my x1 is A by 5, x2 is A by 5, x3 is A by 5. So if I add 5 of A by 5, I get 5 times A by 5 plus 3 times B by 3 plus 2 times C by 2 plus D divided by, how many terms are there? There are 5 A by 5, there are 3 B by 3, and there are 2 C by 2s, and there is 1 D. So total is 8, 9, 10, 11. So total number of numbers is 11. That is why I am writing like this. You may be wondering, why should I write like this? So to know that there are 11 terms, I am writing this 4 terms as 11 terms. As simple as that. That is the crux of this problem. Now, can I say this is greater than or equal to product of all this. So if you multiply a by 5 times, what will I get? I will get a power 5 by 5 power 5. If I multiply b by 3 times, what do I get? B cube by 3 cube. And if I multiply c 2 times, what will I get? C square by 2 square. And d is multiplied once, whole raised to the power of, here n is 11, so it is 1 by 11. I hope this is clear to you. Correct? Now clearly, what is this? This is a plus b plus c plus d, which is nothing but 11. So 11 by 11 is 1. Do you agree with that? This is the numerator is a plus b plus c plus d, which is nothing but 11. So 11 by 11 is 1. Is greater than or equal to a power 5 b cube c square d whole power 11 divided by, I'll just write like this, 5 cube 5 power 5 3 cube 2 square whole power 1 by 11. Now raising it to the power of 11th power, what will I get? I'll get 1 equal to a power 5 b cube c square d divided by 5 cube 5 power 5 3 cube 2 square, not equal to, it's greater than or equal to. Now you cross multiply. When you cross multiply, what do you get? You will get 5 power 5 3 cube 2 square is greater than or equal to a power 5 b cube c square d. So I can rearrange this as, that is a power 5 b cube c square d is less than or equal to 5 power 5 3 square 2 square. All this as 2. Is that clear? Now what I should do? Now you can see clearly from 1 and 2, your 3750 beta is less than or equal to a power 5 b cube c square d is less than or equal to 5 power 5 3 cube 2 square. Correct? If I connect these two, you get this. So clearly this is less than or equal to this. So 3750 beta is less than or equal to 5 cube, I am writing 5 cube again, 5 power 5 3 cube 2 square. Now what is 5 cube 3 cube 2 square? It is nothing but I think this is beta less than or equal to 5 cube 5 power 5 3 cube 2 square divided by, if I do factorization of 3750, which you can easily do, I am getting 5 power 4 into 3 into 2, okay, which is 3 into 2. So if I cancel all this, I get beta less than or equal to 90. Correct? Now since we are looking for the maximum value of beta, what will be the maximum value of beta? It will be 90. So 90 cannot exceed beta, correct? So the maximum value of beta is 90. Just like how I got this. The maximum value of a cube, b cube is this. So same way I got this. Any question? It's very, very easy. If you have questions, please do put your question in your comment section so that I will definitely respond to that. The idea of this problem is breaking this a into a by 5 times, b by 3 times. That is the best part of this problem. Now let's go to the next question. What is the next question? I am given the GCD of Mn. So Mn and a coprime. It is given that GCD of M comma N is 1. This is given to you, and this expression is also given to you. Okay, now what is this expression? It is actually 1 square minus 2 square. Okay, and then this is 3 square minus 4 square plus so on up to 2021 whole square minus 2022 whole square plus 2023 the whole square. This is what is given. Now how you look at this is very important. If you carefully look at this, I can use a square minus b square. What is that? A plus b into a minus b, correct? What about this? A plus b into a minus b. If I continue to do that, it will be a plus b into a minus b. And what is left out? 2023 the whole square. And this is given as 1012 m square n. I have to keep writing that. M square n. Is it clear? Now if you look at all the terms here, you get minus 1 as common. Can you see that? 2021 minus 2022 is minus 1. This is minus 1. So minus 1 can be taken out. Correct? What do you get inside? Don't add, but instead you write 1 plus 2 plus 3 plus 4, so on up to, what's the last term? 2022 plus 2023 the whole square equal to 1012 m square n. Very beautifully it comes. Correct? Now you know this is an AP and there are 2022 terms are there. What is sum of n terms of an AP? N by 2, that is n is 2022, n by 2 into first term plus the last term. I hope you know the formula. N by 2 into first term plus last term. Here n is 2022. Number of terms is 2022. Okay, this is the end of it. This is 2023 the whole square equal to 1012 m square n. Now you have to calculate this. If you calculate this, what do you get? You get 1011 into 2023 plus 2023 the whole square. Correct? This minus is only for this, okay? Equal to 1012 m square n. Now clearly 2023 is common, so I'll take it out. 2023 is common. So what is left out? You get 2023 minus 1011. 1012 m square n. Now 2023, if you subtract this, what do I get? I think I get 2101. Very nice, isn't it? 1012 m square n. So 1012, 1012 get cancelled. Correct? Now what is 2023? 2023 is, I have done prime factorization for this. It is 289 into 7. I have done the calculation, so it's not so difficult. You can break this into 289, which is nothing but 17 square into 7. So clearly m is 17 and n is 7. Beautiful. Correct? Now I want to find m square minus n square. M square is 17 square is 289. Correct? 289 minus 49. What's the answer? It is 249. So that is the best part of it, is looking at it as a square minus b square. There is nothing else. And I'm going to use AP only at this point. Sum of n terms of an AP is used here. Otherwise, it's just normal arithmetic. Now let's go to this another beautiful question. Now it is given that A1, A2 are two arithmetic means. G1, G2, G3 are the three geometric means between three numbers. Then I have to find what this value is equal to. G1 square, G1 power 4, G2 power 4, G3 power 4 plus G1 square into G3 square is what? Okay. Now, you know very well that here you have, if suppose if I take the two numbers as A and B, these are the arithmetic mean between them, correct? So that means there are three terms separating them with common difference D. So what do you know? The common difference will be B minus A by 3, correct? B minus A by 3. Or you can say B is nothing but the fourth term, which is A plus 3D. So b minus a equal to 3d. Therefore, d equal to b minus a by 3. This is how I got this. But this is too lengthy, but it's easy to understand. The difference divided by the common difference gives you the by the number of terms gives you the common difference. So you can avoid this so that you can save some time. So if you have a to b, and if you have, see, this is one term, this is second term, this is third term, so it's three terms. So b minus a by 3 gives you the common difference. Now what is a1? a1 is nothing but a plus d. But what is d? d is b minus a by 3. If I take LCM, I get 2a plus b by 3. This is my a1. Now what is my a2? a2 is nothing but a plus 2d, which is nothing but a plus 2b minus 2a divided by 3. If I take LCM, what do you get? You get a plus 2b by 3. This is a2. Correct? Now actually you are supposed to prove this as, actually I will say it's equal to, actually it's an MCQ question. So I have not done that. So it should be a1 plus a2 whole square into g1 g3 into, you have to prove it is g1 g3. You have to prove this. You have to prove this is equal to that. Okay. Now from this, what is a1 plus a2? a1 plus a2 will be, if you add them, 2a plus a is 3a, b plus 2b is 3b, by 3 will be a plus b. Let me keep this. This is required for me. So that part is completed. Now let us deal with the geometric mean. You have a, g1, g2, g3 are the geometric mean between them. Correct? So what will be the common ratio? 1, 2, 3, 4. So it will be b by a, the whole power 1 by 4. Correct? Or you can say fifth term is a into r power 4. From there you can find r equal to b by a, the whole power 1 by 4. So what is g1 from this? g1 is ar, which is a into a power 1 by 4 by, sorry, b power 1 by 4 by a power 1 by 4, which is a power 3 by 4 into b power 1 by 4, which can be written as a cube b whole power 1 by 4. So don't forget this. g1 is a cube b whole power 1 by 4. Now what is g2? g2 is ar square. What is ar square? A into, it will be, r square is what? B square by a square to the power 1 by 4. So what is that equal to? A into b power 1 by 2 by a power 1 by 2. So this is a power 1 by 2, b power 1 by 2, which is same as a square b square whole power 1 by 4. I want to write everything in terms of a power 1, in terms of power 1 by 4. Okay. Since this is power 1 by 4, I want to write also in terms of 1 by 4. So again I am repeating, g2 is ar square. So I get a power half, b power half, which can be written as a square b square whole power 1 by 4. So this is my g2. Now what is my g3? My g3 will be ar cube, which is nothing but a into b power 3 by 4 by a power 3 by 4, which is a power 1 by 4 b power 3 by 4, which is equal to a b cube whole power 1 by 4. Correct? This is my g3. Now what I want to find? I want to find g1 power 4. I will next find, I will find g1 power 4 plus g2 power 4 plus g3 power 4 plus g1 square into g3 square. Let us see what this is. What is g1 power 4? It is a cube b. Correct? What is g2 power 4? It will be a square b square. What is g3 power 4? It will be a b cube. What is g1 square? g1 square will be g1 square, g2 square. Let me do it separately. g1 square will be a cube b power half, and இது வந்து g3, right? This is g3. and G3 will be AB cube power half. So since the powers are same, it is A power 4, B power 4 whole power half, which is same as A square B square. Correct? Very nicely you got it. Now, if you look at this very carefully, what is common in all this? The common in all this is AB. So I get A square. Now if you group these two, it becomes 2AB plus B square, which is nothing but AB into A plus B the whole square. This is my left hand side. This is my left hand side. So this part you can skip. Okay, if you can always rewind and check how I got this. Okay, that is the left hand side. Now what is my right hand side? My right hand side should be A1 plus A2 the whole square into G1 G3. Now what is A1 plus A2? It's already the A plus B, so whole square means it is A plus B the whole square. Now what is G1 G3? G1 is A power 4, A cube B power 1 by 4, and G3 is A B cube power 1 by 4. So I can write this as A power 4 B power 4 power 1 by 4. You get cancelled, you get AB. So very nice, isn't it? So you can see clearly left hand side is equal to right hand side, hence it is proved. Left hand side is equal to right hand side. So in the MCQ it will be given, you can always do it. Okay. Now let's go to the last problem for the, not last, this is the third question I think, right? Third is over. Now this is the fourth one. The fourth question is S1, S2, S3, S10 respectively are sum of 12 terms of 10 AP. See, S1 is sum of 12 terms whose first term is 1, common difference is 1. S2 is sum of 12 terms of AP whose first term is 2, common difference is 3. S10 is sum of 12 terms of AP whose first term is 10 and common difference is 19. And he is asking me to find the sum of all these terms, sum of all these sums. Okay. Now how do I go about it? Very, very simple. Now, what is sum of n terms? What is sum of n terms of an AP? I'm talking about, I'm trying to find a general formula for this. Sum of n terms of an AP is n by 2 into 2a plus n minus 1 into d. Correct? N by 2 into 2a plus n minus 1 into d. But each one is sum of 12 terms. Each one is sum of 12 terms. So, S12 is what? 12 by 2 into 2a plus 11d. 2a plus 11d, which is nothing but 6 into 2a plus 11d. This is S12. Am I clear? Now, this is S12, okay, of the first term, the first series. Now, I want to know what is my SI is. My SI will be 6 times 2AI plus 11DI. Now I'm going to go, I'm adding all this. So this is like sum of 12 terms individually. Now I'm going to add all of them. Okay. So SI is 2AI plus 11DI. Now what is my AI? Here the first term is 1. Okay. And what is the common difference? If you look at the common difference here, it's 1. The first term is 1. But whereas the common difference is, if you see the difference here, it's an odd number. So it is 2i minus 1. And AI, this is your DI, and your AI is 1. It is 1, 2, 3. So AI will be I. Correct? So SI will be 6 times 2i plus 11 into what is DI? 2i minus 1. Again I'll repeat. Sn is the sum of n terms of an AP. S12, because each one is sum of 12 terms. So S12, I'm trying to find what is the sum of this. S12 will be 12 by 2 into 2a plus 11d. So S12, I got a formula 6 into 2a plus 11d. But each of this S12 have S1, S2, S3, S10 and so on. So that Si will be 6 times 2ai plus 11di. But I don't know what my ai is. But if you look at it carefully, each of your S1, S2, S3, S10, the first term is 1. For S2 it is 2. For S3 it is 3. S4 it is 4. For Si it will be I. And for common difference, S1 it is 1. S2 it is 3. S3 it is 5. S4 it will be 7. So for the ith term, if you see the numbers, they are in odd numbers. So it is 2i minus 1, 2n minus 1. Correct? So this is Si equal to 6 into, if you simplify this, what do you get? 20, this is 22, this is 24i minus 11. 24i minus 11. Correct. Now I want to find sum of 10 terms. So sigma I equal to 1 to 10. That will give me S1, S2 up to S10. That is what he's asking you to find. Equal to 6, you can keep it outside if you want. 24 sigma I equal to 1 to 10 minus 11 into sigma I equal to 1 to 10. You are adding 1. I am putting sigma throughout. Sigma Si equal to 6 into 24 sigma I minus 11 is added 10 times. Okay. So what is this actually? This is 6 into 24. Now what is sigma I? Sigma I formula is n into n plus 1 by 2. But n is 11. N is 10. Okay. Sigma n formula is n into sum of n terms of an AP. N into n plus 1 by 2. But n is 10. So what do you get here? 24 into 10 into 11 by 2. Correct? 10 into 11 by 2. Minus 11 into 1 is added 10 times. When you add 1 10 times, you get 10. So it will be 6 into 2 goes 12 times. So it will be 120 into 11 minus 110. So if you simplify this, I think I am getting 7260. Okay. If there is any calculation, let me know. So again, I want to talk to you about this problem. First of all, sum of n terms of an AP, you know the formula. I'm talking only about this term. For example, S12 will be 12 by 2 into 2a plus 11d. Okay. So that's a general, it's like a sum, it's like sum S1. Okay. Now, like this you have 10 terms. Like this you have 10 terms. So I'm finding one such term, that is the ith term. For the ith term, it will be ai and di. But what is my ai? My ai will be I and di will be 2i minus 1. Once you get Si, but I don't want only Si, I want S1 to S10. So I add all of them. When I add all of them, by simple calculation, you get the answer. Very, very nice problem. See the depth of whatever you have studied in 11th standard sequences and series. It's the same idea. No extra idea is used, but the questions are framed so lovely that you have to think to do these problems. Now let's come back to the last problem for the day. Now it is given that an is a sequence where a1 plus a2 plus a3 up to an is this. I am expected to find 28 times sigma 1 by ak equal to product of primes. And I want to know how many such prime numbers are possible. So I want to know how many such prime numbers are possible. Let us see. Now he has given a1 plus a2 plus a3 up to an. He has said it is n square plus 3n divided by n plus 1 into n plus 2. So I will call this as Sn, sum of n terms. Okay. Now I also want to find what will be Sn minus 1. So wherever n is there, put n minus 1. Divided by, this will be n and this will be n plus 1. Correct? So this is the thing. Now I want to find the nth term. You know, an is nothing but sum of n terms minus sum of n minus 1 terms. Correct? What is sum of n terms? N square plus 3n divided by n plus 1 into n plus 2 minus, what is sum of n minus 1 term? I already have it here. This is n square minus 2n plus 1 plus 3n minus 3 divided by n into n plus 1. I think just I open the bracket. So this is n square plus 3n divided by n plus 1 into n plus 2 minus, if you simplify this, you get n square plus n minus 2 divided by n into n plus 1. Correct? Now you take LCM. If you take LCM, the LCM is n into n plus 1 into n plus 2. That is the LCM. So what will you get? You will get n plus 1 is there, n plus 2, n is not there. So it will be n cube plus 3n square minus, here n plus 2 is not there, so it is n plus 2 into n square plus n minus 2. Now open the bracket on the numerator, n cube plus 3n square minus n cube minus n square plus 2n minus 2n square minus 2n plus 4 divided by n into n plus 1 into n plus 2. So clearly n cube and n cube cancels, and 3n square and 3n square gets cancelled. 2n and 2n gets cancelled, so you are left with 4 by n into n plus 1 into n plus 2. This is your an. But I don't want an, I want 1 by an. So what is 1 by ak? 1 by ak will be k into k plus 1 into k plus 2 divided by 4. I want to find the sum. Okay, I will go to the next page. Just note this. Just a second, I'll take this result. So I have it here. Now what I do? I want to find sigma 1 by ak. Sigma 1 by ak up to how many terms? Up to 10 terms only, but I'll find for n. It will be 1 by 4 into sigma k cube plus sigma 3k square plus 2 times sigma k. Actually, you can open this bracket. This will be ak cube plus 3k square plus 2k divided by 4. This is by 1 by ak. So sigma ak will be 1 by 4 sigma k cube 3 times sigma k square plus sigma k. But you already know, we have done this many times, sigma k cube is k into k plus 1 by 4 whole square. K square into k plus 1 whole square by 4. What is sigma k square? Sum of squares of natural number, k into k plus 1 into 2k plus 1 by 6. And what is sigma k? It is k into k plus 1 by 2. Now if you look at carefully, you can see clearly k into k plus 1 by 2 is common. So what you are left inside? K into k plus 1 by 2. This gets cancelled already. So you are left with only 2k plus 1, and you have a 2 here because this is taken out. So you have k into k plus 1 by 8, right? Actually you can put n, okay? It should have been n. I wrote k. I don't want to change it now. This will be k square plus k plus 4k plus 6 divided by 2, which is k into k plus 1 into k square plus 5k plus 6 by 16, which is nothing but k into k plus 1 into k plus 2 into k plus 3 by 16. Okay. Actually, it is k equal to 1 to n. Okay. It should have been n into, replace k by n. Okay. That's a small error. Now, I don't want to find up to n, but I want to find only up to 10. So wherever k is there, put 10. So sigma 1 by ak, k equal to 1 to 10 will be 10 into 11 into 12 into 13 divided by 16. But the result says 28 into, can you see this? 28 into, so I'm going to multiply by 28. So 28 into sigma k equal to 1 to 10, 1 by ak is 28 into 10 into 11 into 12 into 13 divided by 16. Correct? So what will I get now? This is nothing but I am getting it as 28 into, if I look at this carefully, it is 17160 divided by 16. So if I simplify this, I am getting 30030, which can be written as, if you do prime factorization, it is 2 into 3 into 5 into 7 into 11 into 13. You can cross check. 2 into 3 into 5 into 7 into 11, which is same as P1, P2 up to Pm. So how many primes are there? 1, 2, 3, 4, 5, 6. So M will be 6. There will be 6 prime numbers. So again, I'll just tell you this part, I just skipped it here. So if I multiply both sides by 28, if I multiply both sides by 28, I get 28 into this. If you calculate this, I'm getting this. So if you simplify, you get 30030, which is on prime factorization gives you this. How many product of primes are there? 1, 2, 3, 4, 5, 6. That is exactly what is asking you to find. It is P1, P2, P3 up to Pm. He wants to know how many primes are there. So we have found it. So I hope we have completed 5 questions. I hope you understood these problems. Rewind it and check in case you have any difficulty. And still, if you have any problem, do message me in my comment section so that I can get back to you. If you want me to redo any particular problem also, I can do it for you. We will continue this 5 problem per session in the next video also. And kindly subscribe to my channel and also click the bell icon to get notifications of all videos. Okay, it's great experience. I hope learning these problems. See you again in the next class. Have a lovely day. Bye-bye.